All right. So today is the day where you learn Hody High minus High Ho all over. And you will. Oh, I should bring them in today. Basically, we have not known how to take a derivative of two things that are being divided. You could take the limit and you could do the definition of the derivative. And when we were learning them, and we did the definition of the derivative, since they had simple numerators, I could see the wheels turning, trying to figure out what is the rule. Well, the rule is that we have a top divided by a denominator. So the top is F, the bottom is G. The rule is the reverse of the product rule. So it's bottom times derivative of the top minus top times derivative of the bottom all over the bottom square. So bottom times derivative of the top minus top times derivative of the bottom all over the bottom square. That's hard to say. So somewhere, someone came up with the hi-ho. So it became hi-ho, hi-ho. It's off to school we go to learn the quotient rule.
Did you say next thing's like shoot someone?
Yeah, I have to do. I forgot to do it. I haven't done it yet. So high is for above, right? So something is high. Ho is down low. So it is hi ho. Hi ho. So it becomes ho the high. He giggled. I thought we'd move forward. So it's ho the high, where D stands for derivative. So ho the high, bottom derived the top, minus high the ho. So D again, derivative of bottom, all over ho ho.
Ho squared.
Or ho squared. Like what I just said.
Oh, really?
Yeah, it's like, he said something about ho-hos are delicious, and I was like, wow, I never thought about bringing in ho-hos to give out.
Well, I didn't know you were talking about that, but okay.
Okay, so as you work through these problems, I'm going to label them hi-ho and say my little saying. So it's Hody high, so f prime of x equals x squared plus 1. Derivative of the top is 2x minus, so Hody high minus high d-ho all over ho-ho. Now, do not fall into the trap. We do not FOIL the denominator. We do not FOIL the denominator. Sometimes, not always. But if you don't, there's no need to FOIL it. Okay? So to simplify, you get 2x cubed plus 2x minus 2x cubed plus 2x all over x squared plus 1 squared. So the 2x cubes cancel, and we get 4x over x squared plus 1 squared.
Is that all we have to do?
Mm-hmm.
Oh, that's why. Okay.
And
you distribute the negative to both terms.
It'd just be 1. It's just 0.
So you distribute the negative to both terms?
Yes.
Okay. I was like, wait, but that should cancel out.
Hi ho. Hi ho. So, ho the high. This is where you have to really watch your algebra. The parentheses matter. You got to make sure you encompass things in parentheses. So it's x cubed, derivative of the top is 2x plus 1. So again, those two terms are going to end up needing FOILed. Minus, and again, this is like a bracketed minus, so it's everything that follows becomes negative. So it's OD high minus high DHO all over. Oh well. FOIL, distribute, combine like terms. So again, I'll say the calc part is pretty easy. It's not calc that's hard. It's algebra in calc that is hard.
Can we leave it like that?
Yeah. Because there's nothing to factor by grouping.
Yeah.
All right. So, the next example, once again, is kind of like the product rule. There's one way to do it, and there's another way to do it. So, we're going to do it the quotient rule way first, and then we're going to do it a second way. What?
You can bring up the bottom.
And we're going to see which way is easier. So again, 3x square roots x is really like 3x times x to the 1/2. So these are multiplied. What do you do when you have two things multiplied? You add their exponents. So it's really x to the 3/2. Don't try to put a product rule in your quotient rule. Like, you want to make it into one. So, let's quotient roll it. So, Hody high. So, derivative of x is 1. This is a minus 3. You know, I didn't write it up there. So, it's a minus 3x to the 3/2. So, you have to multiply the negative 3 times the 3/2. So, you get that 9/2 x. And then you subtract 1 away. So, 1 away from 3/2 is 1/2. So, OD high minus high DHO all over ho-ho. Where did you lose me?
The 9/2 x to the half.
So remember, it's 3
Okay.
times this.
Which is really the, okay.
So it's the 9/2. And you subtract 1 away. So if you do 3/2 minus 1, you get 1/2.
I'm just confused where you're getting x to the 1/2.
Because you have to take 1 away when you take the power rule. Minus a power. 3/2 minus 1 is 1/2. 1.5 minus 1 is 0.5. Okay? Clean it up. So a half, x to the 1 half times 1 is x to the 1 half. X to the 1 half times x to the 1 half. Well, half and a half make a whole. So you get minus 9 halves x. Minus, multiply these together. So that's 1 half. But then you have x times x to the 1 half. So 1 minus a half is a half. A negative times a negative becomes a positive 3 halves. X to the 3 halves times x to the 1 half, negative 1 half, gives x to the power of 1. What?
Do we drop the negative 1 half somewhere?
No.
Because I'm not sure how you're getting to 3 halves of that. Because it's negative 3 halves up there.
Negative, negative,
Oh,
positive.
I know, never mind.
Okay.
You just distribute it.
Okay,
Yes.
we can keep going with that explanation.
A negative times a negative is a positive. 3 times a half is 3 halves.
You don't use anything with the exponents?
3 halves minus a half is 1. Something square rooted squared becomes x. X to the 1 half minus 1 half x becomes 1 half x to the 1 half. Negative 9 halves plus 3 halves becomes negative 6 halves x. 6 halves is really 3. All over x. And because we're going to do this again, I just want to simplify it. So you see this is 1 without an x and a fraction and a fraction. So 1 half x to 1 half over x is really 1 over 2 square roots of x, right? Because the 1 half over an x would become negative 1 half, and the 2 would drop down. Yep, and then minus 3x over x would just become negative 3, because the x over x would cancel. So, that is doing this problem using the quotient rule. There's a lot of lines and a lot of exponents and a lot of fractions, right? It's gross and it's messy. If you go back and you think, so if you go back here, or even here, one step before it, we can do what we just did at the end of the quotient rule, where we clean up fraction and fraction, at the very beginning. So what we can do is we can take this one line further and say, okay, I have a single denominator. I can write it under all of my numerators. So the square roots on the right cancel, and then this, exactly, so you have 1 and then you have square root on the bottom, so you subtract your powers and they have like bases, so 1 minus a half would leave me with a half, so I get x to the 1 half minus 3x. And now, no quotient rule, no product rule. We're back to the basics in a power rule. So the power rule says you bring the power down in front, subtract 1 away.
That was so much easier.
Yeah.
So, yeah, exactly. So a lot of being successful in calc is seeing the successes. It's being able to look at a problem and go, I could do it this way, or I can do it that way, and this way is a heck of a lot easier than that way. So the goal as we work through problems and lessons is to try to figure out the right way, or what is considered the easy way. So we talked again about like the product rule yesterday, and we learned that there were times it was easier to FOIL first rather than second, because if we FOILed second, we had to FOIL twice. So that same sort of process can come into play with the quotient rule. So then extension questions would be something like find the equation of the tangent line at a point 1, -2. So what we're going to do is we're going to take that same function and the derivative we just found for it and find its tangent line. Oh, see, this is the one. I'm sorry. Your spacing is goofy. See how the problem got put at the top of the page? I meant to, like, I put the spaces in the wrong spot. Like, that was supposed to be. Do you know what I mean?
No.
Like, this sentence was supposed to be right under the problem. And then I put all the spaces between the sentence and the problem. So, like, the find the equation of the tangent line should have been under the words example 3. Like, it shouldn't be on that. Like, I put the spaces to get to the next page.
But this works the same way this works? That's how you're supposed to find the equation of the
Yeah, all we're going to do is plug these points in. Like, this sentence just goes with example 3.
So you just plug in 1 into the x.
So exactly, what we're going to do to find the equation of the tangent line at a point is you find f prime of the x value. So the equation is 1 over 2 square roots of x. So we're going to take 1 over 2 square roots of 1 minus 3. Square root of 1 is, so 1/2 minus 3. Yeah. Right? So you get negative 2.5, which is really negative 5/2. Yep.
What is that? Under the radical?
It was a 1 that I started to write the letter x. Like I was saying 1 over 2 square roots of x, but like I wanted the right one, so my 1 is crooked.
So you just plug 1 into the already derivative of the equation. That's how I get that.
Yep.
All right.
And then we're just going to plug into our formula. So it's y minus a minus, so it becomes positive 2, negative 5/2, x minus 1. Good?
Is this point so far?
Yeah.
Okay.
So yesterday we looked at the UV problem, and we did the product rule with it, and then you had a couple problems in your homework that did it. Well, now we can take that same concept, but apply it to all different types of products. So we can do the product, the quotient, a whole bunch of different things. So let's look at the first example, which is f times g prime of 5. So again, anytime you take a derivative of a product, you have to use the product rule. So it's always first times derivative of the second plus the second times derivative of the first. So that would be f of 5 times g prime 5 plus g of 5 times f prime 5. First times the root of the second plus second times the root of the first. And then we plug in f of 5 is 1, g prime of 5 is 2, g of 5 is negative 3, and f prime of 5 is 6. 1 times 2 is 2, negative 3 times 6 is negative 18, so we get negative 16. would we anticipate that F divides G would be the same as G divides F? Probably not, right? The F and G are unrelated. They're not inverses or anything. So what we can do is find the quotient rule for each. So again, quotient rule is ho, so it'd be G of 5, D high, so it'd be F prime of 5, minus high, which is F of 5, D ho, which is G prime 5, all over ho ho, or G of 5 squared. Plug in our numbers. So G of 5 is -3. F prime of 5 is 6 minus F of 5, which is 1. G prime of 5, which is 2. All over G of 5, which is -3 squared. And we know that any negative number squared is positive. So we get -18 minus 2 all over a positive 9. You mean functions?
Yeah.
So you get -29. This same concept could be applied with tables. So this again is just one way. Let's look at one more example. So we have G of 5. So we're going to basically do everything in reverse. So it'd be F of 5 times G prime 5 minus so ho d high minus high d ho. All over. Okay, so I'm going to adjust that a little bit because the other day we did something similar. So the other day, right? We did 1 to 39 odds. So what we'll do today, which I know you guys hate, kind of limited. Tomorrow, we're going to review all of the rules. So maybe I'll make another quizzes and we'll actually do like a quizzes for power product quotient. Yep, I know you're not here. So I have a paper, yeah. And then we also have for